This is Visualizing Hypothesis Testing by Darlene Whitlock for Business Research Methodology and Quantitative Stats for the California Intercontinental University. Our agenda shows that we will be first giving some definitions to understand what a hypothesis is. Then we will move on to visualizations of a hypothesis. We will look at 4 different visualizations. The first one is testing for mean. The second is comparing 2 groups. The third is efficiency comparison. And the fourth is correlation test. The last thing we will do is look at some takeaways, creating a hypothesis test and using visualizations. Our definitions. The null hypothesis. This is a hypothesis set up to be rejected in order to support an alternative hypothesis. When used, the null hypothesis is presumed true until statistical evidence in the form of a hypothesis test indicates otherwise. The opposite, or the alternative hypothesis, is a statement expressing a relationship between 2 variables or indicating a difference between 2 groups. The null hypothesis will typically be set to 0 or show that 2 groups are equal, where the alternative hypothesis will state the opposite. Visualization number 1. This is testing for a mean. The y-axis shows the probability of defect, and the x-axis shows how many defects of widgets out of 100. We are looking at the research question. On average, are the widgets from the Acme Widget Company defect-free? Our null hypothesis states that the average number of defective widgets is equal to 0. Making our alternative hypothesis, the average number of defective widgets is greater than 0. Visualization number 2 is comparing 2 groups. You can see from the 2 bell curves that we are looking at the number of home runs and the fractions of teams that are home run hitters. We have the major league team in blue and the minor league team in red. Our null hypothesis states that there is no difference or that the teams are equal. So the major league home run hitters per team equals minor league home run hitters per team. Our alternative hypothesis states that there is a difference and they do not equal each other. So it is written as this: major league home run hitters per team are greater than minor league home run hitters per team. Visualization number 3 is the efficiency comparison. We have a single queue of blue servers, and we are comparing them with single red servers. This is shown on the bell curve, and the bell curve shows the number of hours that they are observed and the number of service per hour. Our research question is, the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? Our null hypothesis says that there is no difference in the mean efficiencies of the red and blue teams. Our alternative hypothesis says that there is a difference in the mean efficiencies of the red and blue teams. You can see that the bell curve is showing a significant difference, and therefore we can visually reject the null hypothesis. Our 4th visualization is the correlation test. In this case, there has already been testing completed. A German study tested how larger industrial use vans utilize gasoline. They plotted the miles per gallon versus the weight of the vans. When they plotted the data on the scatter plot, they performed a correlation test and found the significant correlation. But they forgot to state the hypothesis test in their published paper. When the test was completed, they did find the significant correlation, And you can see that on the p-value, which is below the 0.05 alpha value. So this is the significant correlation telling us to reject the null hypothesis. But they forgot to put in the hypothesis in their study. So our null hypothesis, which is rejected, is that there is no relationship between miles per gallon and the weight of the vans, making the alternative hypothesis true. There is a relationship between the miles per gallon and the weight of the vans. Our important takeaways: when you're looking at creating a hypothesis test, you need to remember that the hypothesis allows a researcher to determine whether or not a theory is valid. The null hypothesis should always be equal to 0 and is always considered true until proven otherwise. Using visualizations allows easy interpretations of data. The visual representations allow researchers to formulate questions and to look at statistical data in an easily observed way. Thank you for watching this video. If you have any questions, feel free to leave comments, and thank you for your time.